Where in the heck did you come from?
Don't you worry about that. Got a question for you. You should take a seat right over here.
Okay.
This question was sent in by Eddie Knox at Cross Arrow Components. If I have a program that was made for a different machine, is there a way to run it on a Thermwood?
Are you serious? You betcha.
No doubt, no pressure. That's what it can do. We say you betcha. You betcha. We got it. You betcha. No stopping. Questions dropping. Thermwood's the answer. You betcha. You betcha. You betcha. You betcha.
Now let me throw something at you. What would you say the most important part is of a CNC router? Most people will say the spindle. And yeah, it's a big deal. The frame and rails are like your bones. The servo motors are like your muscles. And the spindle, that's like the heart, pumping out every cut. And when those systems move in sync, you get something pretty incredible. And just like the human body, all that hardware is useless without the brain keeping everything coordinated. And for a CNC, the controller's the brain. It decides every move, every speed, every tool change, everything. And this is Thermwood's advanced Ultra 6 SuperControl, the most capable CNC control system in the industry. Now here's something a lot of people don't know. About 70 to 80% of all CNC controllers sold today are built overseas. A lot of companies will slap a Made in America sticker right on the frame, but they leave the inconvenient part out. The control isn't. We're the exception. Thermwood's part of that remaining 20%. Our SuperControl is made right here in Dell, Indiana, in the same facility that all our machines are made in. And that's real American-made manufacturing, not marketing. And the best part, all the software, all the programming, every line of development is done right here in-house. That means when customers need new features or improvements, we don't wait on anybody. We build it, we ship it, simple. And that brings us to today's question. Running a program that was made for a different CNC machine on a Thermwood machine. Built right into the interface is our THM Converter. This tool automates program translation by letting you build rules around another machine's G-code structure. Load the program, apply the rule set, and the control rewrites it for our system. No guessing and no rewriting by hand. Now you have two options. You can do all that at the control at your machine right here, or you can do it at your desk. We also offer a product called THM Desktop. It's a Windows PC application that mirrors the SuperControl software on your PC. Now you can't physically run the machine from it, but you can build converters, set configurations, and sync them between both devices. Now I've built a sample converter at my desk to demonstrate exactly how this tool is a game changer. Real quick, I want to say this is not a tutorial. When it comes to the converter, you can get extremely creative, and I could spend hours and hours going over this and talking about all the different things that you can do. So the question today is, if I have a program from a different machine, can I run it on a Thermwood? I think the best approach is to first talk about why that question even came up. So let's jump over to the breakdown board and take a look at what's going on here. For this example, we're going to use two different types of machines. Now this is machine A, built by a manufacturer unknown. And this is machine B, also built by a different unknown manufacturer. Now let's imagine that this box represents some form of a CAD/CAM software. And inside that CAD/CAM is a toolpath. Now when that toolpath is inside the software, we have to get it out of the software in the form of a program, or G-code. And in order to do that, it has to pass through a post-processor. So this represents machine A's post-processor. And this represents machine B's post-processor. Now, looking back at our toolpath, when we go to export this out as a program, we will run it through a post-processor. Now, in this case, it'll be either the post-processor for machine A or machine B. Let's start with machine A. So we run it through the post-processor. When it's done, we have a completed program that is formatted for machine A. If we do the same thing for machine B, We now have a program that is formatted for machine B. Now, if we run these programs on the machine that they were exported for, they will run with no problem. See? Now, let's rewind. Now, if we take a program that was exported and formatted for machine B, and we run it on machine A, well, the outcome isn't always gonna be good. Let's rewind again. Now let's take the program from machine B and take a pit stop. This is the converter. Now if we take the program for machine B and we run it through the converter, it's now ready to run through machine A. You see? Now I'm not gonna spend too much time going over every single rule that I created in detail. I'm gonna grab a couple of the important ones. Now for this example, I created just a generic toolpath in our CAD/CAM software. So let's take a look. This is Mastercam. Oh, if the question does come up, we do offer this. So here's my toolpath. You can see it's just a simple T. We're just gonna simply do a route around the shape. Simple, right? Now, this section represents our post-processor. And in this case, for this example, I'm using the router default. So I'm gonna export it. And this is what it gave me. Now let's take it into THM Desktop. We're just gonna click the open button, navigate to where that was, and here's our program. Now, one of the nice things in our control software is we don't have to run the program and hope for the best. We can run it through the graph screen. And what the graph screen does is it looks at the very first line of code and works its way down and checks every line of code for errors. So when working with the converter, that's gonna be the first step. Identify the areas of your program that need to be repaired. So this is our graph screen button. I'm gonna select it, and boom, we have our first error. Now don't just go and hit OK and skip the error. Read the error. Unsupported G-code, very common one. What you're gonna do is go through this, go to line number 8, we're gonna go back down, and we're gonna identify what that is. As I go through each line and correct them and graph it and identify everything that needs to be corrected, I can then create my rules. So let's jump into the converter. File, convert, and then convert program settings. That's where we're gonna start. Inside of my converter, you will see I have several rules. It's not too many, but these rules get the job done. Like I said, you can get extremely creative with creating rules and going in and converting your programs. So inside of here, you're gonna see something that may scare you. Don't let it intimidate you. It's not hard. So in the converter, we can have a header. What this is gonna do is whatever you have here, it's going to add to the beginning of the program when it converts it. And then we have our line rules. So anything you identify that needs fixed while you're running it through the graph screen, you can create those rules here. Now, on a second note, there might be other items that you need to create rules for that don't necessarily come up in the graph screen. You know, there are certain macros that Thermwood machines like that other machines don't even know it exists. So keep that in mind. And then we have our footer. So we're not gonna look at every rule, but I'm gonna grab a couple rules and we're gonna look at them in detail so you kind of get an understanding of what's going on here. So starting with the simplest rule, the glorified find and replace. So if we go in here and look at this rule says if the line contains S18,000, which is a spindle speed of 18,000 RPMs, then delete the line. Why are you gonna delete the line, Bill? Well, it's because I have another idea. Don't jump to conclusions. Now, when you run it, it deletes that line, and the reason it's deleting that line is because if I move down to this rule, we have some other crazy stuff going on. This is what I was talking about, don't get scared. It's not that bad. You don't even have to use it. So remember, we had the glorified find and replace. Simple. Find it, replace it. Doesn't matter. Super easy. But now, this is where you can get extremely creative. This is where we can utilize Regex, regular expression. Jumping back into THM Desktop, Let's talk about this one. So if the line contains this, what this means is it's searching the program for a T, which is a tool call. This represents, this D is digits 0 through 9. My program, for example, is T5, but it's also looking on that same line for either an M06 or an M6. And then the next step here is to make sure this box is checked. Use regular expression syntax. If this is not checked, this does nothing. Now what this is gonna do is it finds the line that has the tool call and the M6 that's on the same line. It's gonna replace all of that starting with S18000, which is my spindle speed. And then we have the backslash with the lowercase n. This is the line feed function. So it's gonna have S18000, next line, this $1. It's going to replace this field on this next line with whatever was returned from the tool call. The 1 is referring to the first item we searched for. Then M03. M03 turns the spindle on clockwise. We run it, this line goes away, these lines appear. All right, let's take a look at another one. If you look at my program, it has N100, N110, N120, and so on. We don't need these line numbers. So the first character we have here is the caret. This rule only applies to the beginning of the line. So it searches the very beginning of the line for the N. Then we have the digit. It also looks at white space. So if you look back at the program, we have our N and our digits, but then we have a space. This is just going to remove the N, the digits, and the space after it. The final product, the first character is in column 1. Before we convert it, let's recap here. Take a look at the program. This is the code that's currently on the machine. If I go directly to the convert option and I select the converter, and would you look at that? There's that header I had in there. It says converted. Just an easy way to tell the difference. And then we have all of our rules. But the big kicker is what's gonna happen when I graph it. Let's hit it. Would you look at that? Absolutely no errors. There's the T that I programmed in CAD/CAM, but we have one more test. We created these rules based on the way the post processor exported that code. Theoretically, if I have another program that came from the same post processor, then my rules should apply. Let's try it. All right, here's the program before conversion. Let's make sure it doesn't work. There you go, line 8 again. Let's just run it through the converter we made. File, convert, it's converted. But is it good? Moment of truth. You betcha. Thanks for watching. I hope this gave you a solid look at just one of the features tucked away in our control software. If you've got a question about any one of our products' capabilities, send us an email at youbetcha@thermwood.com. All of our products and features are driven by our customers' demands. Our team here at Thermwood is dedicated to making our customers' processes that much simpler. Thanks for watching.
Questions come quick, answer hit ya. Thermwood style, yeah, you betcha.